Welcome to Ola Gold Academy, where we make science subjects such as biology, physics, chemistry, and mathematics easier for students. So if you are new to this YouTube channel, kindly support this channel by hitting the like button, subscribing, and follow and share. So on the board, we're having a topic in physics, which is dimensional analysis. Before this video, we have done a previous video on dimensioning, how we dimension physical quantities, how we express them in terms of mass, length, and time. So on the continuation on dimensioning, we have dimensional analysis. Dimensional analysis just talks about how various physical quantities relate to one another. For instance, we can have like 4 parameters such as rho, we can have area, we can have length, and we can have resistance. Dimensional analysis just talks about how these 4 parameters relate to one another. For instance, these 4 parameters relate to one another under a topic in physics known as electric current. And under electric current, we have resistivity. So these 4 are intertwined by a formula such as resistance to be equal to rho multiplied by length over area. So we have resistance to be equal to rho times length over area. Now, assuming we don't know this formula here, we can use dimensional analysis to find out how they relate to one another. So without wasting much of our time, let's go into the topic. Now on the board, we're having a question which says the velocity v of a wave in a straight string depends on the tension T in the spring and the mass per unit length gamma of the spring. Obtain an expression for V in terms of T and gamma using the method of dimension. Now, the first thing to always take note of when it comes to dimensional analysis is that when the question is being given, some parameters will depend on one, and one parameter can depend on the other, depending on how you are being given the question. Now, let's check this question now. Which one is depending on which one? If you read carefully, you will see that the question says the velocity v of a wave in a straight string depends on the tension, depends on the mass per unit length. So we can see that velocity v is depending on the tension and mass per unit length, which is gamma. Alright, so we can define tension as a force that acts on a spring. What I see, you can define tension as a force that acts on a spring. You can say that, like normally, you can say it's a force that acts on a wire. So that is tension. Okay, with that being done, the first thing to do is to bring out the dimension of these parameters here. So on the board we are having velocity, we are having tension, which is tension is also force. So we have T. Please, they give us tension as T. Don't write F here. Express it as T, not F. And next, we are having mass per unit length, which is gamma. So we have this and we have this. Now, what is the dimension for velocity? Velocity can be expressed as velocity to be equal to displacement over time. So we can express velocity, displacement is a type of length, over time. So we have the dimension of velocity as LT minus 1. So the dimension of velocity is LT minus 1. Okay, tension now. I said tension is a kind of force that acts on an elastic spring or on a spring. If that is so now force is known to be mass times acceleration. Mass times acceleration. That is true. Mass is m, capital M. Acceleration is expressed as LT minus 2. So the dimension of force is MLT raised to power minus 2. So you have MLT raised to the power of minus 2. Now the next thing we're looking at is gamma, which is mass per unit length. Mass per unit length. So can express gamma as mass per unit length, means mass over length. If this is true, then we have dimension to be equal to ml raised to the power of minus 1. Okay, so for gamma we have ml raised to the power minus 1. With that being done, now let's now express how the parameters are dependent on each other. Like I said earlier, I said that the velocity v depends on tension and gamma, which is mass per unit length. So how do you write dependency? Write dependency by using the symbol of direct proportionality, which is v expressed as being directly proportional to tension and gamma. So we have this. Alright, with that being done, we need to eliminate this sign of proportion. So what do? We introduce constants and equal to. So we are going to have velocity to be equal to K tension multiplied by gamma. So our next step here is to let K to be 1. Let K to be 1. So let K to be equal to 1. Alright, let K to be equal to 1. So we're not going to have this. The next step is to now introduce what we refer to as superscript. Let's remove this. Okay, so now I have V to be equal to T, which is tension, times gamma, which is mass per unit length. The next step, like I said earlier, is to introduce what we refer to as superscript. So we're going to have V to be equal to T raised to the power of x and gamma raised to the power of y. So the next thing now is to bring in the dimension. So we're going to have our v to be, the dimension of the velocity here is lt raised to the power of minus 1. So we have lt raised to the power minus 1 equal to, our tension is mlt minus 2. Remember, it's having an index of x. So we're having times raised to the power of x. Everything here is power of x. The dimension of mass per unit length, which is gamma, is ml minus 1. So we have ml minus 1. Everything raised to the power of y. So we have y here. Okay, the next thing is to open the bracket. So we're going to have lt raised to the power minus 1 to be equal to x times 1 here give us m raised to the power of x. n raised to the power 1 here, the power of 1 times x here give us m raised to the power of x. Minus 2 times x give us t raised to the power minus 2x. The next thing is to multiply, is open this bracket also. 1 times y, 1 which is the power of m times y give us m which is the power of y. Minus 1 times y give us l is power of minus y. Minus 1 times y give us minus y. So the next step here is to rearrange in terms of MLT. So we're going to have rearrange in terms of MLT. So we're going to have our LT raised to the power minus 1 to be equal to m raised to the power x. Bringing this m here, we're going to have m raised to the power of y. Okay, next is l. So we're going to have l raised to the power of x and l raised to the power of minus y. Lastly, we're going to have t, which is t raised to the power of minus 2x. Okay, the next step now is to, in indices, if we are having the base multiplying each other, what do? We take the power. The base is multiplying each other, we take the power. So we're going to have our LC minus 1 to be equal to mx plus y, lx plus minus y give us minus y. Then lastly we have c is power of minus 2x. So having this, compare the power. That's the next thing we're going to do. We compare the power or compare the index. We say index, we say power, we say indices, we are still saying the same thing. So comparing power or index or indices, as the case may be, the way you like to call it. So for m first, for m, we're going to have at the left hand side, what do we have for m? Nothing. So we have 0. At the right hand side, For m, what do we have? We have x plus y. So you have equal to x plus y. Now, for L, what do we have? For L, at this side, we have L to be having a power of 1. So we have 1 here to be equal to. At this side, we are having L to be having the power of x minus y. So we're having x minus y. And lastly, for t, we're going to have for t, at this side, we're having t having the power of minus 1. So we have t having the power of minus 1 equal to. At this side, we're having t having the power of minus 2x. So we're having minus 2x. So the next thing here is to look for this one becomes our equation 1. This becomes our equation 2. And this becomes our equation 3. Equation 3. The next step is to look for the equation in which we can quickly get our x or our y. So if we check very well, we can see that from equation 3, we can easily get our x. So you can say from equation 3, we're going to have minus 1 equals to minus 2x. What's the next thing here? Divide both sides by minus 2. So here over minus 2, here over minus 2. So minus 2 cancels minus 2. Minus cancel minus. So we're going to have 1 over 2 to be equal to x. This implies that our x is now equal to 1 over 2. So we have gotten our x to be 1 over 2. The next thing is to put our x here into equation 1. So let me erase here. Put x into equation 1. If we put x into equation 1, equation 1 is 0 equal to x plus y. Our x, we have 0 equal to, our x is 1 over 2 plus y. Bringing this one to this side, we're going to have minus 1 over 2 equals to y. This implies we're going to have our y to be equal to minus 1 over 2. Minus 1 over 2. The next thing is to bring in, let's call this one our equation asterisk. Let's call this our equation asterisk. So let's say, so we can say therefore x equal to 1 over 2, y equals to minus 1 over 2. So what's the next thing here? Put x and y into equation asterisk. So we're going to have our v to be equal to our t raised to power x dot our gamma raised to power of y. So our v now equal to our t raised to the power of x, our x is now 1 over 2 dot gamma, which is raised to the power y, which is minus 1 over 2. Alright, in indices, if we have this a raised to the power 1 over 2, it becomes the second root of a. We have this in indices. So that is true. We're going to have our v to be equal to the square root of t multiplied by, now if we have a raised to the power minus 1, the same thing as we having 1 over a. If we have a raised to the power minus 2, we're going to have 1 over a raised to the power 2. So it means that if we have this negative sign in power, we can eliminate the negative sign by using an inverse. That is true. We can have our gamma to be 1 over gamma raised to the power of 1 over 2. Now, we've already established that if you have a raised to the power 1 over 2, it becomes the second root of that particular number or letter or variable. So we're going to have our power, which is 1 over 2, to become the square root of gamma. That is true. You can have this to be v to be equal to square root of tension times 1. We are going to have square root of tension over square root of gamma. Now, in indices also, or let me say when it comes to solved in mathematics, we have this. If we have this root a over root b, it's the same thing as we having root covering everything, which is a over b. So root a over root b can give us the roots of a over b, this joined to this. Now we can apply that here, so we can have our v to be equal to root of t over gamma. And that is not all. Since we have gotten this, we can now introduce our constant. So we can now have our v to be equal to constant k root of t over gamma. This becomes our final answer. So I'll drop more of examples when it comes to dimensional analysis. This one here is a WAEC question. So I'll be dropping more concerning this topic on my YouTube channel. If you find this video helpful, do want to support this channel, Ola Good Academy, by hitting the like button, subscribing, share, and follow for more. Thank you.